let's talk about finding all of the zeros of a polynomial. There's a couple ways you can do this, but in this video, I'm going to talk specifically about using the rational root theorem to help us find all of the zeros. So let's look at this one. When you're finding all of the zeros of the polynomial, what we're doing is we're saying, I want to know what x values give me a y value of 0. And our rational root theorem says if your polynomial has rational roots, then they're going to be of the form p, where p is a factor of our constant term, or the term at the end, over q, where q is a factor of our leading coefficient. So I'm going to take all of the possible factors of p and all of the possible factors of q and make all the combinations that I can. And when we do that, we're going to have our list of all of the possible rational roots for this polynomial. So let's start with my p's. P's, again, are the factors of our constant term. So 18 is that constant term. All of the factors of 18 are 18, 9, 6, 3, 2, and 1. And all of these could be positive or negative, because 18 could be divided by positive or negative any of these factors. Q's are all of the factors of your leading coefficient. So my leading coefficient is 2, and all the factors of 2 are just 2 and 1. So now I'm going to make my list of possible rational roots, and that's all the combinations of P's over Q's. So my first combination could just be 18 over 2. Second combination, I could have 18 over 1. I'll go reduce these later. Right now, I'll just make the list. Then I move on to my 9. I would have 9 over 2, 9 over 1, and I continue down the row. Now from here, I'm going to go ahead and simplify each of these fractions, and then I'll have my final list of possible rational roots. So this is my final list of possible rational roots. You'll notice that some of them I skipped because when I reduced, they were already in our list. So those few that I just crossed out, my 9 over 1, 3 over 1, and 1 over 1, those were already in my list, so I didn't need to write them a second time. So I'll go ahead and clear that original list of p's over q's, and then we'll just focus on our possible rational roots. So now we have our list of possible rational zeros, but we don't know which ones are our actual zeros. So what we need to do to find that is we're going to use synthetic division to divide, and if something is a 0, then we will get a remainder of 0 when we divide. So I'll set up my synthetic division using my coefficients of my dividend. And then I just pick a number from our list and test to see if it works. I wouldn't start with the highest number in our list, so let's not start with 18, but maybe start with 1 and see if that works. So I will try a positive 1. And it did work. I ended up with a remainder of 0, which means that positive 1 is one of our zeros. It also means that x minus 1 is a factor of this polynomial, but that's not important right now. We're just trying to find our zeros. So 1 is a 0 of our polynomial. Now we can keep going. We continue on with our synthetic division. We can either start back over at the beginning, or we can use this new row that we've created. So I'm just going to start from there, and I will do synthetic division on this row. So I will pick another number. Maybe I'll pick negative 1. And I did not get a remainder of 0. So negative 1 is not a 0 of our polynomial. So I'll go ahead and erase and try another number. Maybe I'll try negative 2. And I did get a 0, which means that negative 2 is a 0 of our polynomial. Now we could keep trying with synthetic division. We could even try our negative 1 and our negative 2 again if we wanted to. But at this point, I've reached a quadratic. And I know it's a quadratic because there's 3 numbers left in my synthetic division. So this quadratic has the coefficients 2 on the x squared, a positive 3 on my x, and then negative 9 is my constant. I could keep trying with synthetic division, but we're not guaranteed that all of my zeros are even in this list. So I might go through the whole list and nothing works for these last couple zeros. So what I'm going to do instead is actually find when does this equal 0 by using either factoring or my quadratic formula. So let me go ahead and clear all this synthetic division. I'll make a note of our couple zeros that we have found, and then we'll solve this remaining polynomial. Okay, so we found 2 of our 4 zeros, and I'm looking for the last 2. So I'm going to find them by solving this remaining quadratic. We can try factoring first. If I multiply, I get negative 18. And 6 and negative 3 do multiply to give me that linear term, which means that I can factor this. So I'll go ahead and do that now. So I just factored my quadratic, and now from here to solve for the last 2 remaining zeros, all I'm going to do is set each of these factors equal to 0 and solve. So I have 4 zeros. I just found x is negative 3 and x is 3 halves, but we also have back in the beginning our zeros of positive 1 and negative 2. So all of my zeros for this polynomial are going to be 1, negative 2, negative 3, and positive 3 halves. So if you plugged any of these in for x, your y value would be 0. Hope that helped. Thanks for watching, and I'll see you next time. Bye.